2 months ago I started working on a new robot. I first made a 3D printed prototype that didn't actually work, but then it evolved into a lighter version that behaved much better. Now I designed the third version that's just made from PCBs. The aim is to have one circuit that acts both as the brain of the robot and its muscle. And the PCBs have just arrived. This is the FR4 PCB that's going to prevent the middle part of the flexible PCB from bending, and also holds the 4 magnets at each edge. When designing it, I limited the width of this PCB to 1mm and its thickness to 0.6mm to make the robot as thin and as light as possible. So that is super difficult to manufacture. PCBA, you are awesome. Look at it, it's so cute. Let's start soldering this thing. So it's almost finished. What's remaining is to solder the rigid PCB, but before that I was thinking of soldering some wires to flash the microcontroller and make sure that everything is working correctly, but I haven't even written one line of code yet, so I need to start coding.
A few moments later.
The LED is blinking, everything is working correctly. Now what's remaining is to solder the rigid PCB, connect the magnets and then solder the battery. This is the LiPo battery I'm going to use for the first test. It's rated at 100 mAh and it's a little bit heavier than the battery I mentioned in the design video, but as I explained in that video, I cannot use this battery because of its current ratings. Okay, so the battery is fully charged. I had to solder this tiny connector with the battery because I forgot to put a kill switch. The robot ended up weighing much more than the 3 grams limit, mainly because of the extra weight of the new battery and the weight of the connector, but let's just hope for the best and try it out. Okay, so this is PCB robot first walking test in 3, 2, 1. The robot's weight was not the only problem that was affecting it. I discovered that the battery's internal discharge current protection was kicking in and forcing a 0.7 voltage drop whenever the coil gets powered, which is quite a lot considering that the nominal voltage of a LiPo battery is 3.7 volts. This is not entirely the battery's fault because it's rated at 2C and I was drawing a little bit more. But before getting into trying to solve this problem, I needed to make sure that the robot can work without the weight of the battery. So I soldered 2 wires to power it externally, but strange enough this also didn't work. After taking a closer look, I noticed this behavior. The forces created by the coil were being lost. My robot sort of works by the principle of moments. So when the coil repels the magnet, it goes up, forcing the opposite magnet to go down. This motion creates a bouncing effect that propels the robot forward, just like the Mark II prototype was doing. But as shown in this clip, the flexible coils are not completely flat and are not allowing the magnets to lay flat on the table. After thinking a little, I came up with an idea that could solve this problem. I removed the rigid PCB and built a new one, so that the magnets face the same magnetic polarity, but connected upside down. This change forced the PCB to push the magnets downwards, and this kind of showed some improvements. Now this didn't solve the problem 100%. The robot was sometimes moving and sometimes not, depending on how flat the flexible coils were. So at this point I decided to try and drive the legs a little faster. I modified the software to change the PWM's frequency every 20 seconds, and the results were quite interesting. Well, that worked pretty well, didn't it? I cheated a little by using a 5V supply, but at least there's hope of this thing actually working. So now let's retest with the reduced voltage and see if it can actually lift the battery. There's definitely a noticeable difference between the two different supplies, mainly because when I'm supplying the coil with 5V, it is almost driven with twice the power. This isn't a big of an issue because all I have to do is remove some turns from the coil to lower the resistance and drive the coils with a higher current. But to test that, I need to design and reorder a new PCB, and I definitely cannot test it with this battery. When I did the battery's weight on the robot, I was quite surprised because it still managed to vibrate around. So I removed the wires and directly soldered the battery, which should not clip the current now since the new PWM reduced it within the 200 mA limit. It worked. I mean, it's a little bit slow, but it's a small step for a PCB, but a giant leap for robotics. I mean, circuits that work. Now the next question is going to be how I'm going to make it move stable and not move randomly around. After reviewing the footage, I noticed that one of the legs was being held stationary. This was happening because the magnets are not all level, so the robot was rotating around the leg that's closest to the ground. To try and analyze the situation a little bit better, I decided to power two legs and drive them out of phase. But before all this, I resoldered a new PCB, because the old one ended up looking like one big mess. Okay, so the new PCB is finished. I have rechecked everything to make sure that it's still working fine. Time for the test. test showed us a clear picture of what's actually happening. The robot is going very slow at frequencies below 10 Hz, but at all the other higher frequencies the system is going unstable, which may be caused by the mechanical system itself. Now the only way I could make it go faster at 10 Hz is by either reduce the overall weight, or by driving the legs with a little more power. Both of these factors depend on the battery, which seems to be holding back this design, so the best way forward is to find better battery alternatives. Anyways, I hope you liked this video. If you want to learn about how I designed the electronics, you can check a design video I made a few weeks ago. The plan is to use this robot in a swarm, so there's still a lot of work that I need to do. So if you want to keep updated, please consider subscribing to this channel. Thank you for watching, and thank you PCBA for sponsoring this project. See you soon.